Okay, so here we are. This is still the spring 2017 final exam review, and this is part 3. And in part 3, we're going to do questions 27 through 40. There's only 40 questions on the test, so as long as you can do all of these parts, part 1, part 2, and part 3, then you should be really ready for your final exam. All right, so for questions 27 and 28, we're going to use the same scenario, and we can actually do this problem in our graphing calculator if you know how to use the graphing calculator, so that might take some practice if you haven't already practiced this. All right, so for the scenario, however, we have a mistake in the equation, so I'm going to fix that first. This should say x equals 75 root 3 t. We didn't have our parameter in there. It got chopped off or something. I don't know what happened, but it should be that. And then you're going to have the y equals equation. So you have an x equals 75 root 3t, and then you have a y equals negative 16t squared plus 75t. And you're going to enter those into your graphing calculator. In the graphing screen, you're going to go to enter graph, and you're going to go to parametric, and then you'll be able to enter the x equation and the y equation. You're going to leave the t value as 0 to 6.28, and just leave the t-step just the way it is. You don't have to change that. Then you're going to hit graph, and the kind of graph you're going to get is a parabola. So you get a parabola, looks like this. Okay, here's your x-axis. And the next thing you're going to do, if you can't see the parabola, or maybe you only see a small piece of the parabola, you need to do a zoom fit. So do a zoom fit, and once you see the graph, then you can do a zoom trace, graph trace. And when that happens, you get a little cursor here on top of your parabola, and you can move that cursor right and left, and you can get all kinds of information. Like you can get this maximum value over here. You can get the value and the distance when the object hits the ground, all of that sort of thing. So you can do that with graph trace. So when we enter this equations into the graphing calculator under graphing parametrics, we get this parabola. You trace the parabola around. The ball hits the ground at approximately 4.7 seconds. Might be slightly different on your calculator, but that's okay. And the distance it has traveled, this would be question 28, the distance it had traveled is around 610 feet. Okay, so we can get that off the calculator. If you need help learning how to do that, or you want to practice in class, just let me know. I will be happy to go over it with you and make sure that you know how to do this problem in the calculator. It's not that difficult. Again, the horizontal direction before it hit the ground was 610 feet, or about, thereabouts. This is an estimate. Another way you can get this answer for the horizontal direction, it says, hint, use the answer from question 27. Once we have our 4.7 seconds, that's our t. So we know that t equals 4.7 or somewhere in there. You can plug that value in for t into your equation and solve for x. So we know that the horizontal distance is x. So we would do x equals, and then 75 root 3 times 4.7, and that would give us also, that should also give us around 610, 611, something like that. Okay? Okay, so in problem 29, we're going to use the graphing calculator again. This time we're going to enter the sum into the graphing calculator and find the answer for the summation of the first 5 terms of this geometric sequence. So you go to calculate screen, and then you click the menu button and go to calculus and sum, S-U-M, and in that menu it's going to give you this sigma, and you're going to just plug all the information into your calculator and you're going to hit enter, and when you do, you get the value of 537,401. All right, so your problem may be just slightly different from this. Remember, I changed some of the numbers on these problems. I didn't want to give you the exact answer that's on the test, but you can plug this into your calculator and very easily get the answer. So again, if you need help with the calculator and you don't know how to put this in the calculator, then you need to ask me for help in class, and I will be happy to show you how to do it, and you can practice a couple of times, and believe me, it's not that difficult. Okay, and the next problem we want to know, this is our insect problem we've been doing. We want to know how many insects are going to be in the, let's see, which generation is it? Suppose the first generation has 60. How many insects will be in the 10th generation? How many in the 10th generation? So that means that we're going to plug the number 10 in for n and calculate this straight on the calculation screen of your calculator. So what is it? 447. All right, so we plug this in and we get 60 times 1.25 to the 10 minus 1, and that's going to equal 447. Now in the next problem, number 31, we're going to calculate the following factorial. You can do this by hand or you can do it straight into the calculator. If you put this straight into the calculator, make sure that this denominator value is in parentheses. If it's not, then that entire 9 factorial times 3 factorial is not going to be in the denominator, and then you're going to have the wrong answer. So just make sure if you're doing it this strictly with the calculator that you put that denominator in parentheses. Otherwise, we can just do this by hand. So 13 times 12 times 11 times 10 times 9 factorial. Now the 9 factorial and the 9 factorial cancel, and then we just have this 13 times 12 times 11 times 10 over 3 times 2 times 1, and we can just start canceling, reducing the values of these numbers, and then just multiply together what you end up with at the top. Okay, so I reduced the 3 with the 12, I reduced that to 4, and I reduced the 10 and the 2, I reduced that to 5, and then I'm just going to multiply 3 times 4 times 11 times 5. And I get 2,680. All right, so number 32, the general manager of a fast food chain must select 5 restaurants from 10 for a promotional order. A promotional program. Order does not matter. So this is going to be a combination if order does not matter. How many possible ways can this selection be done? In your calculator, from the main calculation screen, you're going to go to menu and you're going to pick probability. And then you're going to pick combinations. And in combinations, you're going to select 10, 5. That's 10, choose 5. You're going to hit enter and it's going to give you, all right, 10, choose 5 will give you 252. And then in the next problem, number 33, we're going to do the same thing again, except this time instead of going to combination, we're going to go to permutation. And permutation is the same steps, except this time we pick permutation and we choose 10, choose 3, and we get 720. Okay, problem 34, we're going to find the second term of 2x minus 2y to the 7th power. And you just need to look on your formula chart for your binomial expansion formula. And this is going to be NR or NK, I think it is, on your formula chart. And then you're going to have your x term to the n minus k, and then your y term to the k. And that's going to give you whatever the second term is. So what you need to remember, though, is that k is equal to the term minus 1. Okay, because we always need to make sure that we're subtracting that first term. So term minus 1 is going to give us k. All right, so let's just plug our numbers into the formula, and then let's see what we get. All right, so I've plugged in the numbers. I have 7, that's the power. I'm raising my binomial to the 7th power, so I put n is 7. My k value is going to be 1 less than the term. This is second term, so 2 minus 1 is 1. And then I just fill in the rest of the equation or rest of the formula. My first term is 2x. That's going to be raised to the 6th power because 7 minus 1 is 6. And then my third term here is the y term, and that's going to be negative 2 to the 1st power because k is 1. And then we simplify. All right, so 7 choose 1 is 7, and then 2 to the 6th power is 64. Negative 2 to the 1st power is negative 2, and I need to multiply all of those numbers together. And when I multiply all those numbers together, I get negative 896. And then I have x to the 6th power, because this is to the 6th power, okay, and y to the 1st. So x to the 6th, y to the 1st. All right, so on your problem on the test, it's going to be different numbers, so make sure that you know this formula and you know how to calculate it. Okay, so in problem 35, we want to know what coordinate is graphed here. This point right here is the coordinate that we're looking at, or the plot point that we're looking at. And so we're looking at this angle right here. This is pi over 4. So you know when you write a polar coordinate, you put the radius first and then the angle. So the radius, if we start from the center right here, we count how many rings. 1, 2. So our radius is 2, and our angle is pi over 4. Okay, so 2, comma, pi over 4 is our coordinate for this polar graph. Okay, on the next problem, we are converting the following rectangular coordinate to polar coordinates. So we have an x, y value right now. This is a Cartesian value, x, y. It's a rectangular coordinate. And we want to convert that to something that is r comma theta. So we need to use some formulas to do that. And these formulas are going to be located on your formula chart. So we know that r squared equals x squared plus y squared. That's just the Pythagorean identity or Pythagorean theorem. So if I want to find r, then all I need to do is take my x value, my y value, square those, and then take the square root. That's going to give me r. Okay, so for the r value, we've got negative 2, the quantity squared, plus 2 squared. This negative 2 squared is not negative 4. I repeat, it is not negative 4. Please do not make that mistake on your test. Negative 2 squared is positive 4. 4 plus 4 is 8. So our answer for r is the square root of 8. We could simplify this a little bit further and say 2 root 2, but I'm not so sure that on your test your r value is reduced from the square root, whatever it is, on your test. So if you want to reduce it, or if you want to simplify this radical, you can, but I'm not so sure on the test that it's necessary. So you'll just have to see what your answer choices are. All right, so then that gives us our R value. Now we need to find theta. And to find theta, we're going to use tangent. So I've seen a lot of students get tripped up on this. Tangent is y over x. Okay, oops, and we're going to use tangent inverse. So the tangent inverse of 2 over negative 2. I've seen a lot of students get tripped up on this on the last test. Please don't get confused. Tangent inverse of 2 over negative 2 is just the tangent inverse of negative 1. So you just need to look on your unit circle to see where the tangent inverse is negative 1. And the tangent inverse is negative 1 at 3 pi over 4. So we're going to use, that's in quadrant 2. The other one would be 7 pi over 4, but we're not going to use that because that's in quadrant 4. And our point is in quadrant 2. This point right here is in quadrant 2 because it's to the left 2 and up 2, which puts it in quadrant 2. So we're going to use the angle that's in quadrant 2, and the angle where tangent is negative 1 in quadrant 2 is at 3 pi over 4. So our complete coordinate, I'm running out of space here, the complete coordinate is going to be root 8 or 2 root 2, whichever one it is on your test, and 3 pi over 4. That's it. Okay, the next problem, we're going to do the opposite from what we just did. This time we're going to convert the following polar coordinates to rectangular coordinate, and we're going to use formulas again that are going to be on your formula chart. Now, if I want to find my x value, I'm going to use this formula right here. X equals r cosine theta. And for the y, I'm going to use r sine theta. Okay, so look at your coordinate here. You've got an r and you've got a theta. So all you're going to do is plug those values into your formula and you're going to get your x and your y. That's all you have to do. All right, so 2 cosine pi over 2. 2 times the cosine of pi over 2. Look on your unit circle and see what the cosine of pi over 2 is. You should see right away that the cosine of pi over 2 is 0. So 2 times 0 is 0. So my x value is going to be 0. Now I'm going to do 2 sine pi over 2 for the y value. So sine of pi over 2, if you look on your unit circle, you see that the sine of pi over 2 is 1. 1 times 2 is 2. And that is your x and your y. This one's your x, this one's your y. This is how you find x, this is how you find y. You plug this in for r, this in for theta, and that's all you have to do. It's very simple. All right, for the last 3 problems, it's very, very easy, just identifying these graphs. And let me bring it up a little bit here. Okay, so which graph is illustrated? Well, the easy part about this is that these are all limicons. All right, specifically this one is called an inner loop. This one is called a cardioid, or heart. That's how you can remember it because it's heart-shaped. And this one is called indented loop. So that's it. Good luck on your final. Make sure you're practicing with that calculator. And if you have any questions, make sure you ask me in class. We've still got a couple of days to review before you have to take your final. Please, please come in and ask me if you need help. And that's all we have. Good luck, seniors. and any of you that have to take the final, good luck. Make sure you ask questions if you need help. And good luck to everybody else the following week who have to take the final. I wish you all the luck in the world. And we'll see you around next year, juniors and sophomores.